Hello guys, welcome back to my channel Algorithm Minds. My name is Asan Khurram, and in this channel I teach programming skills in Python, MATLAB and R programming. I also teach Tableau or data visualization tool. So for today's tutorial, I'm going to teach you how you can actually train a linear regression model in MATLAB. So basically what we are going to do, will use this specific function called fitlm, and I will teach you its uses, what kind of further inputs that we can give to this function, and what kind of outputs we can generate in order to do the linear regression model. Okay, to keep two things in mind, that for greater accuracy on low dimension data through medium dimensional data set, you can use fitlm. On the contrary, for reduced computation time on high dimensional data set, like for example you have high dimensional data set, use fit R linear instead of fitlm. Now that being said, for this tutorial I'm going to teach you how we can actually implement fitlm. The first thing we need to do, we actually need to import data. So we are importing pre-built data in MATLAB environment, which is called NY Housing 2005. This dataset includes 10 variables with information on the sales of properties of New York City in 2005. This example uses some of these variables to analyze the sale price. So we are loading this data by the help of this MATLAB command load NYC housing 2005, and it contains a number of variables. Here variables means columns, okay, the columns of data, and based on those some variables, some columns of the data, we will be able to predict the price of sales of the property. Okay, so I'm going to teach you how you can do it. How you can also download the data from directly from NYC open data, but it's up to you. I will upload this code file so you can check it later. Okay, now moving back to our programming section. So the first thing we need to do is actually to convert the column names. For example, we have like broad, we have neighbor, we have building class categories. So we have all this in data in form of capital words. So we want to convert that capital words into lower capital word, lower cap, and we can do that by the function called lower of MATLAB. So here you can see that we are calling NYC housing 2005 data. So this is the data set we have already loaded, which is in the form of tabular form of data, and then we are using dot notation, and then we are calling its properties. So we have a tabular form of data, then we are assessing its properties, and within that properties we are assessing variable names, where variable names we are assessing the columns names. So okay, so here you can see the address, data, the properties of the data, then what are the properties, that variable name, which are the column names. And now we are updating its value by setting equal to sign, then we are using lower function and passing the same syntax. So we are actually taking the column names, the columns of the data NYC housing 2005, and we converting it to lowercase, and finally we are updating its value back to the column names. Okay, so that's how it is. Now that being done, the next thing we are going to create two additional columns. The first column will be the months of the purchasing of the price, purchase of the property, how, like in what month the property was purchased, and the second column will be the date of the purchasing property, like on which date of the month from 1 to 30 the property was purchased. Okay, so here we will create two additional columns. And how we are going to do that, it's quite easy. So here you can see that we are equating its value. First of all, we are using function ymd, and within ymd we are passing one input argument, NYC housing 2005, and with dot notation we are referring to the column of that data frame or the tabular data, which is sales date. Okay, so by using dot sales date, we are referring to that specific column of that data here, NYC housing 2005, and we are taking that data which is in the form of time date, and we are applying ymd, which actually extracts the month from the date, which extracts the day from the date, and which also extracts the year. Now what we are doing here, we are using, first of all, we are getting negating sign, that we don't want to save the value of year. then we are using NYC housing 2005.mm. So here we are creating an additional column by the name mm, and we are storing the values of months in it. In the same way, we will use .dd, and we are creating an additional column called dd, and we are storing the values of date from 1 to 30 in it. Now that being done, the next thing we are going to do, we are actually deleting the column sales date by using this statement here. So we are again calling NYC housing 2005 dot sales date is equal to empty list. You can call it empty matrix. So this is a way how you can actually delete the column or row in a tabular data frame or tabular data of MATLAB. Now once you have deleted that, the next thing we are going to do, we are actually categorizing, we are converting this broad column which has values 1 to 5. Okay, so this broad column has values somewhere from 1 to 5, where 1 to 5 actually represents, where a digit 1, 2, 3 represents a specific location like Manhattan, Brooklyn, Queens, State Island. So what we are actually doing, we are actually changing those values of 1, 2, 3 to this specific string like Manhattan, Brooklyn, Queens, State by the help of this categorical. So what we are doing, we are actually calling the same column broad by the use of dot, and we are updating its value by calling the function categorical of MATLAB. Then we are passing 3 input argument. The first input argument is actually the column itself. The next input argument is we are telling MATLAB what kind of values we want to change. So we are 1 to 5. Here 1 to 5 means 1, 2, 3, 4, 5. And the last input argument is actually the list that we want to update instead of 1 to 5. So that's how you can actually change this value. Now that being done, we say that this neighborhood has actually 2254 categories. So it's not of our use. And in order to have a simplicity of data, we will actually remove this column neighborhood, which can be done the same way by equating its value to empty array or matrix. Now that being done, the next thing we are going to do, we are actually converting the data that is currently present in column building class category to categorical data. So once we done that by use of this statement categorical, function categorical, and updating its value back to the column, let's move on and actually generate the word cloud of this categorical data. So we have like word cloud function, which actually, and then we will actually assign the value of the column we want to generate the word cloud. So NYC housing 2005 dot building class category. So that's how you can create a word cloud. Now that being done, the next thing we are also simplifying. We say that we are only interested in those properties which have 1 family dwelling, which have 2 family dwelling, and which have 3 family dwelling. And we will omit the rows, or we will omit the properties that don't have this dwelling. That is quite easy to do. We have to create a logical index, so to check where are the values that we have these 3 things. Okay, so what we are going to do, first of all, we are going to initialize a variable named idx, and then we will create its value. Then we will use this thing is member to actually check where the values are these things. Okay, so what we are actually doing, first of all, we are converting the column building class category to categorical, or to string, sorry. So we are converting it to string. Now once we are done that, we will see where that specific string matches to any of these things. Okay, these 3 things. If it matches to that thing, then we will have what we we will have a logical true value where we have that specific thing, and we will have a logical false value where we don't have that specific thing. Now that's logical index will be stored here in IDX. Now we are simply going to use this statement. We will initialize the data set or tabular data set name, then it creates this value, and then we will use the indexing logic in order to get rid of those values which don't have that specific dwellings in it. Okay, so that IDX will be a logical true and false, and based on where if the values are false, it will omit those values, omit the rows, and don't include that in the updated one. and here we are using column, which means that we want to include all the columns of that specific tabular data. Now that being done, the next thing we are going to do, we are actually going to convert those dwellings back to numeric values. Okay, so in order to do that, what we are going to do, we are going to use the function rename cats for categorical, and we are passing multiple input argument. The first input argument is actually the column that we want to change, and the second input argument are the values that we want to look after, and third input argument is the updated value, like what value we want to update instead of that specific value. For example, we have 0 1 1 family dwelling, so we will replace it by 1. Now once we done that, we please note that after doing the replacing, we will have a string value in that column buildings class category. Now we have to convert that string value into numeric value. That can be easily be done by the use of double function. So here we are initializing we are calling the same column, and then we are updating this value by applying the double function. So that's what we are actually doing here. Once we have done that, what we are going to do, we will simply can see the summary of that thing, and we can see the summary of sales price. It will give us the maximum, it will give us the minimum, it will give us the median value, and we will do further filtering based on the same index logic. So here we are creating an index logic where sale price is less than equal to 1000. So where the sale price is less than equal to 1000, we are omitting that value and we are setting its value to be empty. Okay, now that being done, let's move on and actually plot the histogram of sales price. This is the value that we actually will be going to predict. So we are using histogram function, and we are using NYSE housing 2005 dot sale price to refer to that specific column. Now you can see that we do get some outliers because majority of the values lie within 5000 or 1000. So how we need to incorporate, we need to get out of this, we get rid of these outliers. So how we can actually do that? We can simply do that by the use of isOutlier. Okay, so again, isOutlier will help, will give us a Boolean matrix where we'll have logical true, logical false in the variable idx. Okay, so we are using isOutlier function of MATLAB that calculates whether there is any outlier in this function in this specific column. If there is a outlier present in it, it will return a true value, and if there is not an outlier present in it, it will return a false value. Now based on that specific Boolean index, what we are doing, we are actually omitting those values where we have outliers. So here by using this empty list or empty matrix here, and using indexing notation. And by the way, if you are getting confused by the indexing notation, I have a highly resourceful and detailed tutorial on that. I will put down the link in the description for you, so you can go and check out that video. Now let's move on. After removing those outliers, let's plot those values again. So we will have a histogram function, and we are passing input argument the specific column of this NYSE housing 2005 dot sale price. Now we can see that it's more or less likely to follow a normal distribution. Now what we are going to do, we are going to partition or split the data set into training and testing. Okay, so we will split some data for training and we will split some data for testing. So how we gonna do that? We will use CV partition function of MATLAB, and here we are setting its size to 0.3. It means that we want 70% of data to be used for test purpose and 30% of data to be used for training purpose. 70% of data to be used for training purpose and 30% of data will be used for test purpose. So once we calculate that specific index, so we are simply going to use this index notation where we have rows and column. For rows, we will have training and within the round bracket C, and test within the round bracket C, and for column we will take all the columns. Now we have to split the data set into training and testing. Now let's move on and actually apply fit lm function of MATLAB, and I will teach you how we can actually implement that thing. So we will initialize a variable named MDL equates value, then we will call the function fit lm. Then we first input argument will be the data set or Tableau data. In our case, it is trained data. Then the second input argument is actually the predictor vars, which in our case is sales price. Okay. Then we have like the feature values that we are going to create the linear regression model on. Okay. So here we have all those values. Okay, so here first of all we are defining that we are telling you predictor variables. Okay, that means that the feature vectors which will use to predict the actual value. Okay, then we are using the response var that will actually tell that fit lm function that now we are going to tell you the target value which we actually want to predict. Okay, so the first one, predict vars, will take feature values, and the response var will take the target value. Now that's how you can actually define it. Once you do that, you can actually see a more representable form of that model in the form of sale price is the model of 1 plus some function of Brout and some function of building class and so on. And it does the calculation, it trains the model on linear regression model, and then it gives you the matrix. Okay, now keep that in mind. The Brout was actually a categorical thing. Okay, so that's why we have Brout, bronze, bronze, Brooklyn, bronze, queen as an individual things. Okay, and we can see that the p-values for some features are high and some p-values of some feature are less than 0.05. If the p-value is less than 0.05, it means that the value is statistically significant. But how we can actually define that this specific column is statistically significant? We can perform ANOVA analysis. Okay, so that is easy to do on that trained model. We will simply use ANOVA function of MATLAB, then we pass trained model as an input argument. Now here will give us the value or the impact of a specific column or feature like Brout, building class category, land square feet on sales price. Okay, and now we can see that Brout is actually 0. It means that it is statistically significant impact on that thing. But we can also see that the building class category doesn't have any kind of statistical impact on, it's not that statistically significant. And we are having the same thing, and the same thing can be seen for month and day. That being said, now one good thing about MATLAB that it gives you the option or features to plot it multiple things, like when creating a model, use plot edit to understand the effect of adding or removing a predictor variable. Now let's move on and actually plot our results. So we will use plot function, then pass model, our trained model, as an input argument. Now you can see that we have adjusted sales price, we have adjusted wall model, and we have like a fitted line here somewhere in the line. Okay, in the power of 10 raised to power 6, and this total line identifies the confidence intervals. And by now you can use a bunch of properties of that trained model MDL by using, for example, you can call the coefficient name by calling mdl.coefficient name. It will give you the coefficient names. Okay, that being said, you can also plot the residuals as well. Now you can also see which residuals are less than a specific value, so it can give you the index of it. And if you look at this data set and you say that, okay, these are the features that are not actually quite responsible to predict the sales price, what you can do, you can actually use a remove terms function of MATLAB to remove a specific features or specific columns from that trained model and make it more optimized. Okay, so right now we are using remove terms function, and then we are passing two input arguments. The first input argument is actually the function itself or the trained model itself, and the second input argument is in the form of string. There we actually emphasize what kind of value we want to omit, or we can get rid of this trained model. Now you can see that this newly trained model, it doesn't include the term day and building class category, which we can see that doesn't have significant impact on the sales price. And now we can see that the just R-squared value has increased up to some extent. Now one additional feature of this trained model, what you can actually do is apply step method by using step function and passing three input argument. The first input argument is actually the trained model itself, and n step then 30. What it actually does, it actually takes each term, improves the model by adding or removing variables using steps. The default upper bound of the model is a model containing intercept term, linear term of each predictor, and a product pair of distinct predictors. And the default lower bound is the model containing an intercept term. So it will start as a bottom value, it has the highest value. So it will keep on adding those terms until it sees like, okay, so C specifies the maximum number of steps in taken as 30. The function stops when no single step improves the model. Okay, it stops at when there's no significant improvement in the p value or r value. So once we done that, now you can see that we do have an increased r value 0.285. That's good. And then we'll explore the residuals. And in the same way, we can actually predict the newly tested data, and we can see the results as well. Okay. So I hope this tutorial have been helpful for you. If you have any questions regarding today's tutorial, feel free to write down your comments. I will be happy to help you out. Thank you for joining me. If you are just a beginner in MATLAB programming and you want to learn MATLAB programming, I have a highly dedicated resourceful videos that teach beginners how to code in MATLAB. So I request you to go and check out that video as well. Thank you for joining me. If you have any question, feel free to write down your comments. I will be happy to help you out.